Welcome back. Now the important concept is type of relation. Types of relation. The first relation is null relation or void relation. As we have said that any relation is a subset of A cross B, or if we are defining in a set A, then A cross A. Okay, we are taking A cross A because we are interested in a relation on a set A. Phi is a subset of each and every set, so phi will be a subset of A cross A. So this relation will be null relation. Let us take one example. Let A be a set of all the boys in your school. Let x, y belongs to R. We are defining R. xy belongs to R if and only if x is sister of y. Then this relation will be null relation. Why? Because x is a boy, y is a boy, xy belongs to A, x and y both are boys, so x cannot be sister of y. This is a null relation. Take one more example. A equal 1 2 3 4 5 6. R is a relation defined on A between xy such that x minus y equal 12. Obviously R is going to be 5. So this is a null relation or void relation. The second type is universal relation. Universal relation. What does it mean, universal? Each element is defined, is related. Each element is related to all other elements of A. In fact, A cross A is the universal relation. So let us write it. A is non-empty set. A cross A is a subset of A cross A. So by definition, A cross A is a relation This A cross A is said to be the universal relation when R is equal to xy for every xy belongs to A, then this is a universal relation. Let us take an example. A X is student of KVOF Dum Dum. Now we are defining a relation R in the set of A xy such that difference of height of height of X and Y is less than equal 5 meter. What do you think about R? X and Y, all the student of A will be related with one another because the difference of height, in fact the maximum height will somewhere between 1.5 meter to 2 meter, so the difference is not going to exceed 5 meter, so each and every xy will be related. Okay, this R is actually A cross A. This is the universal relation. Next type is identity relation. What is actually identity relation? A is a set, non-empty set obviously. R equal A belongs to A. This is identity relation, and we write symbolically it is an IA, identity on A. Now there is one more, reflexive relation, and don't confuse this relation with identity relation. Reflexive relation, I am writing the definition actually. A relation is reflexive if every element is related to itself. That means if A belongs to A, then AA must belongs to R. a relation R. If these two are very much confusing in nature, okay, but let me give you the example. Let A equal 1 2 3, then IA is 1 1 2 2 3 3, and this relation 1 1 2 2 3 3 and 1 2, both of these are reflexive relation. This is reflexive and this is also reflexive. This is reflexive, but this is not identity relation, whereas this is identity relation. So this is the smallest reflexive relation. This is identity relation, is the smallest reflexive relation. Are you getting my point? Each reflexive relation is not an identity relation, whereas identity relation is always reflexive relation. Now one more example on reflexive relation. Let n be the set of natural, n is the set of natural. Example 2. R is a relation on n defined by R xy such that x is less than equal y for every xy, sorry, as, can we write x is less than equal x? Yes, it is always true. So R is reflexive. Now how to prove the relation is reflexive? You have to prove that R contains all XX type, all a relation R is said to be symmetric if AB belongs to R, then BA must belongs to R. This is the definition. Let us understand this concept by an example. Let L be the set of all lines in a plane. R is defined in L, L1, L2 such that L1 is parallel to L2. Okay, so if L1 L2 belongs to R, take any two lines. L1 is parallel to L2, it means L2 is also parallel to L1. That means L2 L1 are related. So this is symmetric. Now let this is R1. I am once again defining another relation, R2, L1 L2 in the same set. L1 is perpendicular to L2. L1 L2 are related. What does this mean? L1 is perpendicular to L2. You can say L2 is perpendicular to L1. That means L2 L1 are related. We are taking one example which is not symmetric. Let A is the set of human beings, in a particular city. Let us take Kolkata. In Kolkata, we are defining one relation such that xy, it will contain all xy, such that x is father of y. Let AB belongs to R. That means A is father of y. Sorry, not y, it should be B. Yeah, A is father of B. Now can B be father of A? No. So BA doesn't belongs to R. Doesn't belongs to R. So this relation is not symmetric. Can you think of more symmetric relation? X is father of Y, X is mother of Y, X is sister of Y, X is brother of Y. All these relations are not symmetric. Think why. But if I define this relation, X is friend of Y, friend of Y. X is related to Y if X is friend of Y. This is also one way of writing xy belongs to xy belongs to R. This is one way of writing X is related to Y. If and only if, so not if and only if X is friend of Y. What do you think of this relation? Will it be symmetric or not? I think this will be symmetric because every human being is, 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 every human being is friend. X is friend of Y, so Y must be friend of X. X related to Y, it means Y related to X. So this is a symmetric relation. What about enmity? X is enemy of Y. Y is an enemy of X. So these are symmetric relation. I hope you understood the topic symmetric